this problem requires the understanding of conservation of energy. So, what is the conservation of energy is? Energy can neither be created nor can be destroyed. It can simply be transformed from one form of energy to another form of energy. In this particular problem, it is asking you to calculate or to understand how does the kinetic energy or potential energy changes to the kinetic energy. So, but the total energy, what you call the mechanical energy, which is the sum of kinetic energy and the potential energy, always remains constant. What's simply happening is the potential energy is changing into the kinetic energy. So what is asking here? So you have a bead here and it is sliding down this wire, and then you have to find it out what is the potential energy of the bead at this point, at point A. So the potential energy in a system is equal to mgh. So the potential energy, I'm just writing PE at point A. Okay? This is equal to mass times gravity times the height. HA. This is HA, the height. This is 100 centimeter. So I'm just going to change this 100 centimeter to the meter. And this is equal to 1 meter. Okay? And this is 80 centimeter. So the 80 centimeter is equal to 0.8 meter. Everything has to be in SI system. So let's calculate this value then. The mass, what is the mass? This is 2 gram. Okay. Mass is 2 gram. So the mass is 2 gram. You have to change this into the kilogram. How do you do that? 2 divided by 1000 is kilogram. So the mass is 2 over 1000. The gravity expression due to the gravity is 9.8, and the height is 1 meter. So just plug in all the numbers, and the answer you will get is 0.0196 joule. This is the answer you get. This is for number 1. Okay. And now what is asking the problem number B? It is asking you what is the kinetic energy of the bead at point B. What is the kinetic energy? So remember, once this bead slides down, all the potential energy at this point is converted into the kinetic energy at this point. So the kinetic energy at this point is the same as the potential energy at this point. So the life is pretty simple here. So you don't need to do anything here. The kinetic energy at B is simply equal to potential energy at A. And this is equal to 0.0196 joule. Okay? And now number C now. This requires a little bit of thinking. What is asking? What is the speed of the bead at point C? It is asking you to find the speed at point C. So at point C, so when the ball slides down, all the potential energy at this point changes into the kinetic energy, and this kinetic energy again changes into the potential energy. But at this point, it does have both potential energy and the kinetic energy, because it is not at the same height. Okay? So what's the height difference? So all the height difference here between this point and this point will be in the form of the kinetic energy. Let me write down this way. potential, the mechanical energy, the total energy, I'm just writing down total energy, total mechanical energy, total energy at C is equal to potential energy at point A. What is the total energy? It does have the potential energy and the kinetic energy. So have the kinetic energy at point C and potential energy at point C. This is equal to is the potential energy at A. I'm just deriving an expression just to make life simpler. Okay, I probably need to use a blank paper here. Okay. Okay, let's continue here. Let's go back here. So what is the kinetic energy? The kinetic energy is equal to half mvc squared, the velocity, and the potential energy is mg times hc, and the potential energy at point A is equal to mgha. So the velocity, I can calculate the velocity from here. A vc squared, this one would be mg ha minus hc times 2 divided by the mass. This mass cancels out. So the velocity at point C is simply equal to 2 times g times ha minus hc. Okay, so this is the expression to calculate the velocity. So you know now 2 times g. What is the value of g? 2 times g is 9.8. Height is, the first height is, if you remember, is 1 meter, and the second height is 0.8 meter. So you just have to go back and forth just to look at this figure here. You see this height is 80 centimeter, which is equal to 0.8, and this is equal to 1. So if I just plug in all the values, the answer I'll get is 1.98 meter per second. 1.98 meter per second. Okay, the last part it is asking you is calculate B. What is the speed of the bead at point B? So I'm just going to use the same formula here. This time, this would be 2g HA minus HB. Okay? Two times 9.8. What is the height here for HA? At point A, this is 1 meter. Now at point B, if you see at point B, the height is, it is starting from this point. So the height is 0. This height is 0. And if I plug in, the answer you'll get is 4.43 meter per second.